I'll start with the ColBERT-Zero. So yeah, as you said, basically the idea was saying like currently the common practice in order to train multi-vector models is to say start from a dense model, do a knowledge distillation step, and profit basically. And the question we asked was, is that adaptation actually enough, or is it leaving performance on the table? And well, the spoiler is it is leaving a lot of performance on the table. And basically, to test that, what we did is we used the nomic and embed data mixture. Because first of all, it's public, which allows for easier setup and reproducibility, which is very important. We love open science. And second of all, because there already were like a dense model trained on it called modern BERT embed, so that allowed to like compare easily our results with like what would happen if you start from a dense model and do the knowledge distillation step. And yeah, afterwards, like we use the typical pipeline, which is used to train retrieval models, which is a three-phase pipeline with first doing unsupervised contrastive training, which is a large-scale step in which negatives are found in batch. So that allows you to use a lot of data, but obviously it's pretty expensive to run all of this, followed by a supervised contrastive fine-tuning step, in which the data quality is higher because we use mined hard negatives instead of in-batch negatives, and then the infamous knowledge distillation step. And what we found was, first of all, that indeed, if you do these three steps instead of just doing the knowledge distillation step, you get a new state-of-the-art model for models sub 150 million parameters. With training on the nomic embed data, which is public, we managed to achieve actually better performance than GTE modern ColBERT, which was trained on private data. So that's huge. But also the practical insight that came out of this was that, as I said, by far the most expensive step is the unsupervised contrastive retaining step. And we found that actually you can skip this one, do the supervised and the KD step, and get more than 99% of the benefits, while being basically 10 times cheaper because you could skip this very expensive step. So yeah, I think that's the big picture of the paper. I don't know if we have time to go a bit in the details on the impact of the prompt. Because I know it's something that Antoine spent a lot of time on, so I'm sure.
Yeah, I don't know if it's very interesting for the people, but yeah, we had a lot of result about using a prompt or not using a prompt. The main result was that since when you are reusing a model, for example, when you reuse the unsupervised one, the costly one, if people use the prompt, you should use the prompt because you better align the setup. If you are training for long enough, then you might go away with it. But it is very good to align the setup of the unsupervised with the rest of the setup. Um, but it doesn't seem to be all of the big picture. And yeah, it seems that using a prompt with ColBERT model, just disclosure, it's not like a prompt like really prompting the model to create a specific representation. It's really a simple prompt saying this is a query and this is a document. This is not like a prompt here thing. We observe that using this prompt, you get better result than not using prompts, even if you do the whole pre-training with it or without it. And we did a lot of ablation to understand why. We still are not entirely sure why. But yeah, I think one plausible explanation is that the multi-vector model uses it as query expansion. Essentially, it gives it more token for representing the document and the query, which are like global kind of token, not related to any of the actual token. And it can be used to store global information about the query and the document. The idea of why this is because in the original ColBERT, there was query expansion token, but skipping all of the detail with the new model, you cannot do that because of flash attention. So we don't have query expansion in the newer ColBERT model. And so adding this prompt might allow the model to redo some query expansion. But yeah, that was kind of the detail, and we tried very hard to understand really a disentangle why we had better results, but we still don't have the full picture, essentially.
And one thing I forgot to mention, which may also give us a nice segue to talk more about Pilate, is that basically, like, the key thing that enabled us to do all of this experimenting with pre-training or not pre-training a ColBERT model was that we relied on Pilate, and that made everything like run smoothly, let's say.